Hey everyone, Professor Baldwin here with yet another factoring problem. Once again, notice that we only have two terms, and there's a subtraction sign between the two, so we have either a difference of squares or a difference of cubes. Well, we know that we have a difference of squares because the first term and the second term both have items in there with an exponent of 2, meaning that they're squared. What we need to determine is how to set them up so that it's one whole thing that we'll call A minus some other thing, B, so that we can factor it as A minus B times A plus B. So if we start with 4A squared minus 9B squared, is 4 something squared? It is. It's 2 squared. So we can rewrite that as 2 squared times A squared. And we can do the same thing with 9. 9 is 3 squared. So we have 3 squared times B squared. Now, using our rules of exponents, we can combine those, which gives us 2A squared minus 3B squared. And this is in the format of the difference of squares formula above, so we can factor it. We know that our A is 2A minus our B, which is here 3B. And our second factor is 2A plus 3B. I'm confident that I factored this correctly, but let's do a check. And since we have two binomials, we'll check with FOIL. Our first two terms are 4A squared. Our outer are 2A times 3B, and our inner is minus 2A times 3B, and our last is minus 9B squared. Notice that these two middle terms cancel each other out. So we're left with 4A squared minus 9B squared, which is the binomial we were asked to factor. So this is the correct factored form for that difference of squares.